Okay, for the Hooke's Law Lab, we're going to use this simple apparatus here. It's basically a spring attached to a stand, and there's a tray to put masses on it. When you put the mass on, it goes down a certain amount. And you can measure how much it's gone down by because there's a little scale on the bottom here. So at the very start, I align the scale with the 0 mark, and I look on horizontally and I can measure how far the pan has gone down. So I'll be adding masses and it will go down by different amounts, and I'll record how far it's been displaced. I've got another one here. You can see it's got a very different spring on it. So I put 100 grams on this one and it goes down by just a centimeter or so. I put one on this one and it goes down like 10 centimeters. So one of the things we're going to be measuring here is something about that spring and how does it respond to mass. And then we'll be graphing this and looking for the exact mathematical relationship, and not only talk about the force, but also the energy. And so by going through the process that's laid out in the lab, you'll be able to hopefully come up with that expression for energy as it relates to force and the particular spring and the amount of displacement. So I'm just going to add masses on here. Make sure it's at 0. It is. All right, and I'll record the masses on the screen behind me as I go, and you'll be able to collect the data alongside. So 100 grams looks like about 0.8 centimeters. And then we'll add another one. I'm at 2.8 centimeters. So these values are about plus or minus, about plus or minus 1/10 of a centimeter. Got that written down there. That's like 4.8. It's been very consistent. Okay, so there is the data, if you can see all that. For the displacement and mass, you'll want to convert the mass into force and plot that with force along the y-axis and displacement along the x-axis.